Hello everybody, and welcome to part 1 of Senior Developer in 24 Hours. Today we're going to be doing the introduction. So the first thing is, why am I even doing this in the first place? Well, in my career as a software developer, one of the questions that tends to come about is, what is the path for a junior developer to progress to a senior developer? So the idea of this series of videos is to be able to create a formal path that can describe, hey, these are the steps that you can take to go from junior developer to a senior developer. And the idea is that this will be compiled into a living document with all of the information. And, we will have a living document that can be updated of what it means to be a senior developer with the latest tools, the latest trends, the latest technologies, and so on. Because at the end of the day, what are the repercussions of you as a software developer not keeping up to date? Not keeping up to date with the new technologies, new methodologies, new trends. This is a field that is constantly changing. We're still in the infancy of the field. So there are a lot of things that are moving that we have to keep up with. Okay, who am I? My name is Andrés Solarte. I have over 20 years of experience in IT. Throughout those 20 years, a large chunk was spent working as a Java developer in multiple fields, healthcare, e-commerce, things like that. I have also worked as a Linux system administrator, both in the data center as well as in the cloud. And right now I am working as a cloud technical consultant for Google Cloud. However, I want to note that this series of videos and all of the material that's going to go into the book are my personal opinion and do not reflect in any way the views of my employer. But having said that, throughout my career, I have seen the evolution of the craft as we've moved from the data center to the cloud, as we've moved from the monolith into microservices and things like that. And that is the kind of experience, that's the kind of knowledge that I want to lay down in this series of videos. Okay. Now that we've started to think about this, the first thing that we want to do is we want to start defining some of the terms that we're going to be using. So the first thing is, what is a senior developer? Especially within the context of this series of videos. Okay, so, if you were to think about a senior developer, obviously it is a person that spends a significant part of their day developing code. But beyond that, they do a lot more things. In particular, a senior developer is a force multiplier that enables other developers to operate at their maximum level. A senior developer is also somebody that keeps a vision outside of the ticket-based workflow. And we're going to go into a lot more detail about what this means and how exactly it plays. But a senior developer is the person that keeps a more holistic view of the component that we're working in. How does the work that we do fit within the broader system? What are the implications of the work that we're doing? What is the implication of the work that other people are doing in terms of our component, and all of those things. Finally, a senior developer is going to help grow the skill set and capabilities of the team. They're going to help the team keep up with the latest technologies and methodologies. And part of that, well, is exactly what we're doing here throughout this series of videos. All right, so who is this course for? This course is for developers that already have a solid understanding of the basics of programming. We're not going to cover the basics. We expect that you at least have some level of knowledge, and we're going to build upon that. Similar to that, we're going to assume that you have some basic knowledge of development technologies, development methodologies such as agile, and maybe hopefully a little bit of waterfall, even though that is somewhat of a derogatory term. But again, we are not going to teach the basics of those methodologies, but we're going to talk about how do we fit within those methodologies. This course is for somebody that has already been working in the industry, particularly as a backend developer, for a number of years. This is not for somebody that's just coming into the industry. This is for somebody that has, at the very least, a couple of years of experience writing software within an enterprise environment. And, this is obviously for somebody who wants to grow their career. Not all of the junior developers want to take the extra responsibilities that come with a senior title. So this is focused on people that actually want to take that next step and move up into a more senior role. And as I mentioned before, we are going to focus on back-end development. Some of the things that we're going to be talking about will also be relevant for front-end development, but by and large, at this level, you want to start specializing, whether it's front-end development, whether it's back-end development, whether it's something else. This series of videos is mostly for people that are focused on back-end development. Okay, so what is the distinction that we're making between a senior developer and a junior developer? And this very likely will vary from organization to organization. Organizations have different terms that they use. Sometimes people will get a certain title because of HR policy situations where they need to give somebody a certain title to make sure that they can give them the proper compensation, things like that. But for the purposes of this course, these are the differences that we're going to be working with. Okay, so a junior developer is somebody that is focused on tickets. They take a ticket, they start working on it, they commit some changes, they get those changes approved, they close the ticket, and then they pick up another ticket. Now, a senior developer will spend a very large part of their day also, picking up tickets, working on them, and closing those tickets. But besides that, they need to keep a holistic view of the application and how does the application fit within the broader ecosystem in which it is working. At this point, nobody's writing an application that doesn't have any dependencies with any other application, so it is part of the responsibility of the senior developer to keep in mind, those interactions, those dependencies. Junior developers tend to be more focused on functional requirements. For example, when I click a button, something should happen. Senior developers also will spend a large portion of their day addressing tickets that deal with functional requirements, but they will also take into account a lot of the non-functional requirements. And we're going to describe a little bit more what non-functional requirements are. Okay, a junior developer by default will normally start writing code. They get a ticket, they open up their IDE, they start writing code. Senior developer should be a little bit more mindful of, hey, should we even be writing this code? Should we be reusing another system? Should we be reusing a library? Should this even be done at all? So it is up to them to keep an eye out of what the ticket is doing and what are the implications of the ticket and whether there might be a better way of doing things. A junior will have a more limited view of the software development lifecycle. For the most part, a junior developer will be concerned with, again, picking up a ticket, opening up the ticket, working on the ticket, closing the ticket. A senior software developer will be concerned with the end-to-end software development lifecycle. From the beginning of the project, how do we bootstrap the project? How do we write the code? How do we deploy it? How do we maintain it? How do we support this code in production? So they tend to have a much broader view covering the end-to-end software development lifecycle. Okay, so here are a few things that a software developer is not. You do not become a software developer just because you have worked writing code for X number of years. Again, in some organizations, having been there for X number of years will maybe get you the title of software developer, but for the purpose of this course, being a senior software developer is going that extra step, taking that extra responsibility. A senior developer is not necessarily the person that writes code the fastest. There are some junior developers that are very, very talented at writing code. But normally, the role of the senior developer is not only to write code, but also to make sure that the whole team is moving as fast as they can. And that doesn't always mean just writing code as fast as you can. A senior developer is not necessarily somebody that has intimate knowledge of the company's code base. Again, they might have been at a single company for a long time, they might have that knowledge, but also senior developers are a very desired role. So, when organizations tend to bring in senior developers a lot to be able to help them with a particular project. So a senior developer is somebody that should have the capability of going into an organization, being able to ingest a particular code base relatively quick, and quickly providing value to that organization, even if they haven't been there for years. So normally a senior developer would go into a project, they would ingest the code base to have a basic understanding of how things work, and then rely on other people that have been there longer as SMEs, subject matter experts, to fill in the gaps that they might not be 100% knowledgeable of within that particular code base. Okay. Another role that tends to be somewhat popular out there, and that is the architect. Sometimes it is called enterprise architect. And in here, we're talking about the internal architect. Sometimes architect can be part of the sales organization for a company, and they tend to help out the sales effort. But in here, we're talking about the architect that helps build things internally for a company. Okay, so what is the difference between an architect and a senior developer? An architect is going to have a holistic view of the whole system. They tend to figure out what are the interactions between all of the components without really understanding the internals of each component. A senior developer is going to have deep knowledge about how a particular component works, but they're also going to have a somewhat broader understanding of how that component fits within the broader ecosystem, but maybe not the whole system. Architects tend to be a lot more concerned about non-functional requirements. For example, is the system going to be reliable? Is the system going to be scalable? Is it going to be secure? Things like that. Senior developer, they have to balance things a little bit more. They have to work on the functional requirements, but they also have to keep in mind the non-functional requirements. And again, in a lot of these areas, the architect should work side by side with the senior developers to be able to achieve the goals of the organization. The architect tends to work at the organizational level. In a single organization, you're going to have a very limited amount of architects. On the other hand, senior developer, they tend to be deployed more at the team level. So in any given organization, you're going to have a lot more senior developers than architects. Part of this is why being a senior software developer is such an enticing career path, because there are many opportunities in pretty much any organization to be able to go in and create a significant impact. Okay, so what this course is not. First thing, this course is not training for computer science heavy interviews. A lot of large organizations have some very computer science heavy interviews. There are a whole lot of resources out there in the internet to be able to practice those kinds of interviews. There are a lot of places where you can read the computer science theory. We are not going to be covering those. As I mentioned before, this is not a bootcamp. We're not going to be covering basic programming training. We assume that you already have that kind of knowledge. We are not going to be covering agile methodologies. Again, you should have basic understanding of agile methodologies. What we're going to talk about is how does a senior developer can effectively interact with those agile methodologies. Okay, here are the topics that we will be covering. The first thing, we're going to start looking at how do we build an application from the ground up, or how do we go into a project and start providing value from the ground up. The first thing is, how do we identify and analyze user requirements? In some organizations, we're going to have business analysts, maybe QA people that are going to help us identify and analyze these users' requirements, and they're going to give us the tickets that we can work on. In some organizations, it is up to the developers to do all of this work. But regardless of which one is your case, it is important to have a good understanding of how that process works so that we can have useful feedback in having high quality tickets that will lead us to having high quality software. How do we bootstrap a project? Let's say that we're starting net new or effectively net new. How do we build something that can get us up and running quickly and effectively? Part of this is how can we automate the building of the project? What are the techniques that we can use to take away some of the manual work that could slow us down? We're also going to be talking about techniques that can help us keep the team on track. And this is very important. It doesn't matter if you're doing agile, it doesn't matter if you're doing waterfall. In any large organization, you're going to have dependencies with other teams, maybe with external systems, and sometimes those dependencies are not going to align properly. So we're going to talk about how we can work around those issues to ensure that we keep the team on track, that we keep them productive, and that we move as fast as we can, given the constraints that happen whenever we're building something as complex as a software application. We're also going to be talking about how can we create good and effective unit tests. Any kind of automated testing is vital for us to have high quality software, so we're going to go into details about what makes a good unit test, what are some of the techniques that we can do to write effective unit tests. We're also going to be talking about integration testing. How do we go from testing the smallest unit of code that makes sense within our language to testing something big, maybe a little bit bigger, maybe all the way to end-to-end testing. And again, the idea is that we want to remove some of the manual work to ensure that we have something that can allow us to progress faster. We're also going to be talking about code quality and some of the tools that we can use to ensure that we're writing code, not only that it works, but that it is going to be maintainable. Make sure that we are not introducing technical debt when we're solving problems. Making sure that we have a good handle on the complexity of the code that we're writing to make sure that whomever comes after we do is going to be able to maintain this code. Because let's face it, not every project that we're going to work on is going to be a net new project. A lot of the work that a back-end senior developer is going to do is going to be going into an existing code base and taking ownership of it. whether it's because we need to maintain it, whether it's because we need to add new features to it, whether it's because we need to maybe modernize that legacy code base into something new. We are going to have a good technique to be able to go into that code base and make it our own. Okay, we're also going to be going very deeply into non-functional requirements. Basically, it's everything that happens around the actual functionality that the user is trying to perform. For example, how secure is it? Sure, the software works, but does it work in a secure manner? Does it even work reliably or not? How can we build software that is reliable? How can we measure reliability? What is the right level of reliability that we want to achieve to ensure that we find the right balance between reliability and being able to make changes to the application? Scalability and performance. How fast should we be able to operate? What are the use cases in terms of performance that we need to be able to make sure that we cover? How can we ensure that the code that we're writing is maintainable? And potentially, how can we ensure that it's extensible so that other people can integrate into our software, that they can write plugins, that they can write, modifications to be able to achieve their own goals within the parameters set forth by the component that we are working with. We are also going to go deeper within the frameworks that we use, within the languages. Part of the knowledge that a senior developer brings to the table should be a very deep understanding of the language, of the framework, things like that. And there are a lot of things that we can Google. But we also want to make sure that we understand some of the basic concepts, some of the basic mechanisms that are normally leveraged in frameworks to make some of the really magical things happen. So we're going to be talking about annotations and how does meta-programming work, how all of those things work. And this is important because as a senior developer, we want to understand the implications of adding, for example, a new annotation that is going to make our code transactional. Hey, what does that mean? If we add an annotation that is going to provide security for us, what does that give us? So understanding the framework is one of the key parts that we're going to go deep into, that we're going to examine some of the patterns that are used by popular frameworks, by popular languages, so that we can provide that level of expertise. We're going to be talking about releasing software. What are the mechanisms that we can use to properly schedule and properly execute releasing software? So, sure, we've written the code. How do we get it out there? And that, there are multiple ways, and we want to touch upon those to make sure that we have a plan whenever the time comes to ship the code that we've written. We're going to talk about microservices. What makes a microservice a microservice? What are the boundaries of a microservice? When does it make sense to break something up? When does it make sense to merge things together? And, microservices have become a very popular trend, but just like anything, it can be abused. We're going to talk about stateful and stateless application. When should we go with one versus the other? What are the implications? What are the drawbacks? We're going to talk also about databases and persistence. Basic understanding of how do we interact with our data stores. We are also going to be talking about event-driven applications, because not every application that we write is going to be a request-response application. We want to have some good understanding about event-driven applications, the patterns that we use there, what are the cases in which an event-driven application would make more sense than creating a request-response-based application, things like that. we are also going to be talking about running in production. Namely, how do we automate the deployment? How can we get to the point where we feel confident that pushing a single button, or maybe pushing no button at all, is going to allow a code base that we're confident is running? How can we ship that code base to production? How can we set up monitoring for the application once it's in production? And these are some topics that have a lot of overlap with what the operations team will do, or DevOps or SRE does, but we want to provide the perspective from the software development side to make sure that we make it as easy as possible to have good quality monitoring for our application. And we're basically doing this why? Because we want to simplify debugging and troubleshooting our application in production. As simple as that. So we want to have all of the things in place so that debugging and troubleshooting become a little bit less painful. We're also going to be talking about rollout and rollback strategies, because unfortunately, sometimes we make mistakes, we have to roll back, we have to fix things. So having a good plan in place to be able to tackle those things is going to get us very far. Finally, we are going to be talking about the team. Again, a senior developer, they tend to be a force multiplier when they are in a development team. So it makes a lot of sense to talk about how we can become that force multiplier. And the first thing we're going to talk about is effective code reviews. How can we make sure that code reviews are beneficial not only for the code base, but for the team? We're going to be talking about mentoring and building a team. This is something that I'm personally passionate about. I love seeing teams grow. I love seeing people progress in their careers. And obviously, to have those things happen, especially, to make sure that those things happen without people having to switch organizations, I want to have a good mentoring mechanism within my team, and I want to build an effective team. And a lot of these things, they can only be done throughout continuous professional development. And hey, continuous professional development is exactly what we're doing with this series of videos. So if you're interested in this, you're welcome to follow along. All right, let's talk a little bit about the format of the course. So we're going to be looking at half-hour weekly videos. We're going to do a total of 48 videos. That's going to give us 24 hours. The material that we're going to be talking about is going to be condensed into an ebook that will be freely available. The ebook will be a living document and will run slightly behind the videos. So I'll try to keep up with the videos. I'll try to keep up with the book, but probably the book is going to be trailing along a little bit more. There will be code samples for some of the things that make sense. Again, my main focus throughout my career has been Java. So most of the code samples are going to be in Java, but I'm also going to add some extra examples in other languages such as Python, Go, and Node. All right, so in the next video, we're going to be talking about identifying and analyzing user requirements. And finally, thanks for watching. Don't forget to subscribe. Again, we have 47 videos to go. Hopefully you'll be able to join us for this journey. You can also follow me on Twitter, you can follow me on Mastodon, or you can hit up my webpage. Thank you, and see you next week.